Okay, welcome everybody for your robotics programming here. So right now you're in the middle of somehow driving this robot around and potentially being able to stop at a wall, look around, do a bunch of different things. And you may notice that your code is kind of ballooning, getting bigger and bigger and bigger, especially if you're trying to navigate that maze right now and your robot comes to a thing. You look left, you have to check for the distance. You look right, you got to check for the distance. Then you've got to turn or drive. And you're going to find yourself doing large chunks of code over and over and over again. And anytime you start to see that as a programmer, you want to figure out how we can make this more efficient. So I want to introduce an idea called functions into your program here. And functions are basically little instructions that you can kind of package up and you can repeat over and over again. And you only have to uh, package them or define them once, and then you can use them all over the place. And it makes your code a lot more readable and a lot more easy to type out, honestly, in the end, especially for repeated things that you're going to find yourself doing, like checking the distance or turning or driving forward. As you see here in this basic code, this is the Laird's what did I call it here? Neck driving test code that you may have put in here. So things that I see happening very often in this code, or at least once, and I'm going to have to expand later on, are things like getting the distance there, or driving, or stopping, or driving forward. And you'll notice to drive forward, it's 4 lines of code essentially. To check the distance, you're talking 10 lines of code here. And if I have to check the distance in several different places, this is going to get ugly. So what I want to think about is in my program, what am I going to do very often? And I can actually, just like I made my life a little easier at the beginning here by defining my pins and giving them names, I can do that for repeated processes. So for instance, this line right here, this is if something's close, then I'm going to stop, and that's 4 lines of code here. But I may do that lots in my program. So I'm going to create a function up top here, right at the beginning. This is usually where we put them, just so people know what's going on before our setup and before our loop. Um, so in this case, I am going to make a function called stop, and it's just going to stop the robot. Now, in order to define your own functions, you have to do a couple things. First of all, we already have 2 functions that are being used here. One's called setup and one's called loop. These are built into Arduino, but we can make our own. For instance, I'm going to make a function called stop. So I do just stop, and then I put the 2 brackets and I define it just like so, and it finishes it off for me here. And in between, I would put all the things I want to do when I want my robot to stop. Now, there's one extra thing, so I know that I'm not actually calling this function or using it at the moment, and that is you have to define at the beginning what kind of information this function will send back to the main program. And for most of our robot ones, at least here at the beginning, we don't send anything back. The setup program just sets it up and we don't go back to the main program. We just leave it be and then we move on. Same with the loop, it just loops and then moves on. Our stop, we're not sending any information back like you may want to with the look ahead. But in this case, you would normally put what kind of information it was. It may be an integer, it might be a floating point number we talked about, but in this case it's nothing, so we call it void. So I say void stop, and that is the definition of my program. Now, I can go down here and I can go steal this code here. If something's close, then I am going to do these 4 things. I turn all of my motors to power 0. So I'm going to copy that and just tab in and paste. Now I don't have to tab as far as rules with the programming language, unlike say Python if you've done any of that. However, it makes it nice and easy for me to read. So I know that the stop function is here. These are all the parts of the stop function, and then the stop function ends right there. So I've now defined this. I've grabbed all of these lines of code and I've wrapped them up into something called stop. Now, when I define this function, this doesn't mean the robot's going to stop right here. It's just saying I have now made a little shorthand, a little note about that. But in my function, or sorry, in my main program now, if I wanted to stop the robot, I no longer have to say, turn off this motor, turn off this motor, turn off this motor, turn off this motor. I can replace that all with a single line of code, and I can just say, stop. Now, it's also have to have a semicolon at the beginning, but this also makes this way more readable because I can look here and I can say, well, if something's close, I'm just going to stop. Now I could also turn my head one way, turn my head another way. I've also got another series of things that I do quite often here, which is to drive forward. I turn on the right forward motor, I turn on the left forward motor, and I turn off the reverses here. So I could also do another function up top here for something that I'm going to use quite often, which is called void, and I'll just call it drive. Bracket, bracket, open the parentheses, and then I'll go steal that code right there. And I'm going to grab all of that. In fact, this time I'm just going to cut it, and I'm going to replace it with drive, like so. And then I'm going to go back up to the top, and I'm going to add all of that programming in there. Tab, 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 just to clean it up a little bit there, make it easier. So um, the beauty of this is you only have to define them once. I've set them up at the beginning of my program, and now as my code goes along, if I ever need to drive forward, all I have to say is drive. If I need to stop, I can say stop, and I can start to look at other things like even this piece of code here, which is to get the distance. It's lots of different lines of code, and we could wrap it into a function to make my life a little bit easier. And you'll see that I've added a little demo here on Moodle for you with where's my program? My Laird's Basic Obstacle Avoidance with functions here. Now, I'd really love for you to try and build this on your own, and mine might not work for you, but you can see that I've put in some pretty common things that I may want to do at the beginning. Here I've done the setup, but here I've created a turn left function that allows me to turn my robot left. I could do a turn right function. I've got a look ahead function. Notice this one returns or sends back the distance that that something is. I've got that there, I guess. And then the loop. Now, if you look at my program here, I didn't make a stop one, but that would have been a great idea in this code, so I could do that. But notice here, I've looked ahead. If I see something, then if the distance is clear, I'm going to turn right, or here I'm going to turn left, or here I didn't even do a drive forward. That would be way easier to clean up. And if you're going to steal my code there, I highly recommend it, but you should make this even more efficient by adding some of your own functions to make that program really kind of read almost English-like as you're going through the loop. You can say, if you see something, stop. If you go forward, if it's clear, drive. If you have to stop and you look left and the path is clear, then you could turn right or you could turn left. And you can hopefully make your program a little easier to read and a little easier to manipulate in the future. So keep going. Try and finish and get that maze going over the next couple classes so that your robot can drive through and navigate that basic maze.